Hello and welcome to this training. I'm Sepide Soltanyanzadeh, Applications Engineer with the DLP team at Texas Instruments. In this training, we'll talk about brightness requirements and trade-offs in DLP display systems. The main objective of this training is to help product developers who are new to DLP technology understand brightness and the related system trade-offs. So let's go through the agenda for this training. First, we'll go through an introduction of why brightness is an important design consideration in DLP display and projection systems, and review some basic definitions to better understand the terminology in this training. After that, we'll go into the design considerations section and review the main factors affecting brightness, such as screen size and ambient light. We'll also go over some trade-offs that need to be accounted for when designing systems using TI DLP technology. In the summary section, we'll tie the information together and introduce additional resources to learn more about DLP display technology and jumpstart your design. Now let's get started with our first section. So why is brightness important? TI DLP products are used in a variety of applications, ranging from classical projectors to more recent applications, such as smart home displays, digital signage, laser TV, wearable displays, and much more. As such, systems using DLP technology can be varied in terms of their system requirements. Brightness requirements are one of the key considerations to account for when designing any projection system. The two most frequent questions from customers who are new to TI DLP technology are, given the application and user environment, what is the right brightness for my product? Another question is, given specific power, size, and cost requirements, what is the maximum brightness that my product can achieve? The first question is often asked by product developers for whom image quality is the highest priority, such as in cinema display products. Whereas the second question is often asked by product developers who have certain technical constraints, most frequently power, size, or cost, which will ultimately constrain the maximum brightness of the projection system. Now let's go over some key terms that will be mentioned in this training. What is projector brightness and what is image brightness, and how are they different? Projector brightness is the amount of visible light emitted from a projection system. It's measured in ANSI lumens and is independent of image size. With DLP technology, it's possible to create projectors spanning a broad brightness range from 30 lumens to 60,000 lumens. Projection systems can include several different types of illumination sources, including lamps, LEDs, and lasers. Factors that impact projector brightness include illumination source type, illumination source output capability, illumination source input electrical power, optical design, and the DMD or digital micromirror device chip size. Image brightness is a measure of the brightness of an image reflected off of a surface, and is measured in nits or candles per square meter. Image brightness depends on the image size, projector brightness, and the projection surface. For example, a projector with a particular projector brightness in lumens will generate higher image brightness when the light is concentrated within a smaller image. Now that we've introduced some key concepts, we'll see how we can determine the right brightness for a system and the trade-offs associated in system design. Many factors come into play when we want to determine a projection system's brightness requirements. The first factor is ambient light environment. Another is screen size. The impact of these two factors will be discussed further in the next slides. The next factor is video content type. The brighter the image content, technically the higher the average picture level is, or the more colorful the image content, technically the more saturated the colors are, the fewer lumens are needed to create an image that appears bright or is acceptable for a specific application. The final factor is the projection surface. For the purpose of this training, we assume a non-glossy white surface. For applications requiring a different type of surface, such as patterned or colored surface, more image nits may be required. Now let's delve deeper into the impact of ambient light on perceived image brightness. Ambient light levels vary significantly across different in-application environments. Here we show an example of the impact of different ambient light levels on the perceived image brightness using a projector outputting 410 lumens. With increased ambient light level, the image starts to look more washed out. Since the projector brightness, image size, and projection surface are all constant, the image brightness created by the projector is the same for all cases. However, in a brighter ambient environment, the perceived image brightness is lower. This is because the ambient light alters the contrast ratio of the image, making the image in the brighter environment look washed out. We can also calculate the actual image brightness using the equation mentioned in the brightness requirements and trade-offs application note. As mentioned, the projector brightness is 410 lumens. The screen used in this example is a white projection screen with a gain of 1. With a known image diagonal size of 40 inches and aspect ratio of 16:9, we can calculate the width, height, and area of the image. Plugging these values in the formula, the image brightness is about 296 nits. Based on the example shown here, we can see that this level of image brightness looks too bright for a darkroom environment such as a movie theater. That's why the cinema industry standard for image brightness is relatively low, about 50 nits. As shown in the previous slide, ambient light level of the goal application is a major factor for designers to determine how much brightness they will need, and it should be considered early on in the design of DLP display systems. Here you can find a summary of suggested image brightness levels for various ambient light conditions based on empirical testing by TI. For example, for an outdoor application with indirect sunlight, an image brightness of more than 600 nits is suggested. Now let's see the impact of screen size. Using a constant projector and altering the screen size, we observe different image brightness levels. Note that the image brightness in these cases are calculated using the formula mentioned in previous slides. The values for different screen size scenarios are shown in the table. Essentially, the same amount of light needs to be distributed over a larger area for a larger image, making it less bright than a smaller one. Also, the brightness of the 20-inch image is over 600 nits. Referring to the table mentioned in the previous slide, we can see this specific projector will be effective outdoors with a small image size. Nevertheless, if we need a larger image, then this projector would be more suitably used in an indoor environment. Here we've summarized the suggested projection brightness in lumens as a function of diagonal image size and image brightness levels. For example, if we need a 10-inch image with 100 nits of image brightness, the suggested projector brightness will be 10 lumens, which can be designed using a 0.2 class DMD. This DMD can support up to 150 lumens. Note that these calculations assume a projection surface with a reflectivity of 80%. When projecting onto a non-ideal surface, the actual lumens desired may be different than those shown here. A typical white wall has a reflectivity of 80%, but colored paints can reduce this number. TI DLP display DMDs are categorized into two types, Pico and standard chipsets. Pico DMDs are smaller in size and support up to 1500 lumens, which make them a good choice for small and low power applications. Standard chipsets can support up to 10,000 lumens and are generally suitable for large display high brightness applications. You can find the links to these portfolios in the descriptions for this video. Now that we've gone through the various factors impacting brightness requirements, let's get a general idea of the trade-offs in a DLP display system when there are limitations such as size and power. These variables are listed in the table. Some of them will be constant once the production-ready optical module is chosen for the design. An optical engine or module includes the DMD chip, the illumination source, and the required optics package in a module. There are many production-ready optical modules provided by optical engine manufacturers, which can help facilitate your design for DLP projection systems. For more information about optical module specifications, please refer to the Optical Module Specifications application report. Once an optical module is selected, we'll have two main variables available for tuning: the illumination source drive power and the illumination thermal solution. In most cases, a higher drive on illumination source will result in higher brightness. However, the cause for this higher brightness is the heat created in the system, which will require a more robust thermal solution. For example, if you want to design a projector embedded in a phone, there is limitation on size and cost. Therefore, we probably cannot include a large thermal solution in the design, which in turn leads to lower source drive power and lower brightness. In contrast, if the goal is to design a tabletop projector, the requirements on size are relaxed, allowing for a larger illumination thermal solution, higher source drive power, and therefore higher brightness. It's also worth noting that higher illumination source output will also result in a higher heat load on the DMD. Therefore, at some point, the size of the DMD thermal solution may need to be increased as well. While brightness, power consumption, and size are typically the most dominant system requirements, there are two additional performance parameters that product developers should consider: projection lens throw ratio and optical engine contrast ratio. Please refer to the TI DOP system design brightness requirements and trade-offs application report for more detailed information regarding these factors. Now we'll provide a summary of the main points in this training and also resources to help jumpstart your next DLP display system design. In summary, DLP technology enables a wide range of projector brightness levels from 30 to 60,000 lumens, which can be used to design products for a variety of end applications, such as classic projectors, near-eye display, laser TV, and many more. The main factors designers need to consider early on in their design for the projector brightness and for a specific end application are the ambient light level, screen size, video content type, and the projection surface of their application. Designers also need to be aware of the limitations in the system, which will lead to some trade-offs in their design. You can get started today on your next project by visiting the TI DLP website and going through our various resources. To learn more and get started on your design, please refer to our application reports on brightness requirements and trade-offs and optical module specifications. You can also find links on this video page to contact optical module manufacturers for high-volume, production-ready optical engines. If you're looking into designing a custom display system, we have partners and design houses that can help and facilitate your design. Also, there are many easy-to-use evaluation modules, such as the DLP Lightcrafter Display 2010, 3010, and 4710, which can be purchased to evaluate TI DLP systems before starting your own design. The links for all of the mentioned resources can be found in the description of this video. Thank you for your time and watching this video.